Recording. Hello, good evening. My name is Musasizi, alongside my colleague, Kasakya, Denis. In this presentation, we shall be taking you through the write-up of our project titled Reinforcing Human Participation for Post-Highest Loss Prediction in Sparse Learning. Uh, this project, uh, this project, we looked looked at different keywords like knowledge distillation, reinforcement learning, deep learning, sparse learning, post-harvest loss, machine learning, application, and food security. So in this presentation, I have different things we shall cover, which include introduction, created works, problem statement, research questions and objectives, then research contributions and methodology. I shall take you through this part, and then my colleague will take you through the next parts. Uh, Beginning with the first part is the background and introduction. First of all, the project is about predicting post-harvest losses. We should ask ourselves, what are post-harvest losses? So post-harvest losses is the reduction in quantity of harvests from the time they are picked from the field to the time they are consumed. So that process contains the storage, exportation, uh, preparation. So all this entails to what we call post-harvest losses. So this post-harvest loss poses a significant challenge in global food security, especially in developing regions. And this is always because of different factors like inadequate storage, poor transportation infrastructure, and different environmental conditions. So predicting these losses is always hard, and uh, currently, local methods are being used to predict these losses, uh, and recent advancements in machine learning and AI offer promising approaches for addressing the issue. So, this project, we shall integrate more advanced techniques like integrating reinforcement learning and deep Q networks to develop a predictive model to predict post-harvest losses. I shall also leverage knowledge distillation, uh, sparse learning, and then also sparse learning to predict post-harvest losses. Uh, we incorporate this to optimize computational resources and reduce model complexity. This is making it more scalable and replicable in resource-constrained environments. So the next part is about related works and recent trends for literature review. What do other people say about post-harvest losses? Or what has currently been researched about post-harvest losses? So post-harvest losses are a challenge, as we told you, with an estimate of about 30% of agricultural production being lost from the point of harvesting to consumption. So traditional approaches are being used currently to predict these losses, which include statistical modeling and expert systems. Um, then application of deep learning has grown in recent years, like convolutional neural networks in image-based agricultural applications. They're effective in detecting early signs of storage and signs of storage in stored produce. Then reinforcement learning represents a paradigm shift in predictive modeling by making predictions by the sequential decision-making process. So the deep Q network architecture is reformed for prediction tasks, prediction of post-harvest losses. Then knowledge distillation is an approach where that we always reduce deployment complexity for different models, where quite large models shall be replaced by simpler models, reducing the requirement of more computational resources. Then sparse learning will enable us deal with post-harvest prediction, post-harvest loss prediction, even if we have some missing data, maybe from environmental monitoring. Then we have a problem at hand that can be informal, domain specific and computational specific. So when we talk of domain specific, we look at the problem on the side of the domain, agricultural domain. How is it a challenge to predict post-harvest losses? How is it affecting farmers predicting post-harvest losses? Then when we talk of computational problem, we look at how is it a challenge for the people predicting post-harvest losses to achieve it successfully and cheaply. So in developing this model, of course, we face some challenges like high dimensional data, limited real computing resources, and real-time processing demands. So those are computational problems. And then we have contributions were made the current research, like developing machine learning frameworks, integrating deep networks, node registration, sparse learning, post-harvest and improving post-harvest loss prediction. Then optimizing predictive model that balances accuracy and computation efficiency, making it suitable for resource-limited environments. Then introducing sparse learning techniques to reduce model complexity, and also demonstrating effectiveness of knowledge distillation and transferring knowledge from complex models to lightweight models. Then also providing insights to post-harvest loss predictions using XAI techniques to improve model interpretability and trust. Then perhaps some such questions and objectives. What's the aim of this research? Or which research questions are we trying to answer through implementing this project? So the project is aiming at developing an optimized reinforced deep human distribution framework to predict post-harvest losses and address critical challenges in agricultural settings. Research explores how effectively transfer knowledge from complex models to resource-efficient implementations, and yet maintaining accuracy through innovative sparse learning techniques. The objectives include creating adaptive mechanisms, designing real-time predictions, and balancing model sophistication with farmer usability. So have a methodology or the architecture to predict post-harvest losses, to build this model to predict post-harvest losses. We went through data collection, pre-processing, and then using the deep network to predict post-harvest losses, and then training the model, validating it, and then performing evaluation metrics. I think my colleague shall take you through the next parts of the presentation. Let me call my colleague to share the screen and continue.
Yes, hello. Kasakya Denis and I'll be taking you through the dataset description and exploratory data analysis. Yeah, without that section obtained, we are able to make EDA, and these are the results we were able to obtain. Our dataset was sourced from GitHub, and of course, it had features that's community previous loss percentage, current loss percentage, and the year of loss percentage. And we use this to predict future post-harvest loss percentages. Amongst the visualizations we were able to get from our dataset during EDA exploration, we had the bar charts, the violin plots, total loss commodity over time, this above graph, and scatter plot as well. Yeah. Then after that, this is the the results of the models we were able to train. We trained 10 models. We had the linear regression model, based deep neural network, deep Q network model, Bayesian, naive Bayes model. We had the random forest decision tree, graph neural network. Yeah, that's what I'll be telling you and reading the results you able to obtain. So among this, the visualizations you obtained from training the models, we hope as you have a learning curve for the random forest model, as far as others is for the best deep neural network. These are the table of results we were able to obtain for the evaluation metrics. We're using classification metrics, that's as accuracy, precision, recall, and F1 score. Some of the models, of course, were regression models, but we were able to convert the categorical data into numerical so that you could be able to evaluate based on a classification metrics. So yeah, so we have more outputs here, the graphs from the visualizations of the models. Post this research enhances post-service loss prediction using deep Q networks, registrations, fast learning, and the key outcomes of this will cost accuracy. We need to lower computation costs and real-time deployment potential. While the challenges we face, we are limited data, of course, deployment constraints as well. Had to gather more data, we had to, of course, change the data sets as well. So that probably to prove a problem in our case. In the future works, of course, we intend to focus on expanding dataset by integrating real-time sensor data and satellite imagery to improve prediction accuracy. And also, of course, adaptability across different crops and regions to make the system more reliable. And for further research, we want to integrate advanced reinforcement learning techniques, such as multi-agent systems, to include multi-agent systems that are we include the multi-view systems so that we can be able to advance and work on the shortcomings of what we have been having facing in the project. Yeah, I was telling you if you're going to be focusing on expanding dataset by integrating real-time sensor data so that you can improve our prediction accuracy and to be able to adaptable to different crops and regions. Of course, shall need to use lower power IoT devices to improve real-world deployment. As well, shall integrate advanced reinforcement learning techniques using multi-agents and also explore explorable AI to improve model transparency and trust. Also, you need to collaborate with agriculture experts and policymakers who can help us implement these solutions. In this acknowledgement, we just appreciate support and guidance of our university staff, especially our tutor, as well as our colleagues and friends who have been there for encouragement and support throughout the research journey. Thank you for listening.